Quick video on circle theorems. Okay, so one of the things that's come up is that circle theorems seems to be a bit daunting because there's so many rules that you need to remember. So all I'm going to do is quickly show you the overview of these rules. So the first one actually covers that rule in just a few different views, okay? So the normal one that we see is this one by here, where we've got 2x and at the center of the circle, and then at the circumference it's just x. And the same applies here. It's just out of proportion, so making it look a little bit different to what you're used to. And again, it's slightly saying, but it would be the same as if it was over here, okay? It's just they like to put it in different places. There's nothing to worry about when you see it like that. Other times I've seen it really awkwardly done. Again, it is still going from that position, so just be aware of that. It just looks awkward. And the famous one is the one at the end. This actually is another circle theorem in itself because it's a semicircle which creates the 90 degrees. Nice little rule here. So the opposite angles, so A and B will add up to 180 and they have to touch all four sides. It can't be like this shape by here because that's not touching all four sides. Okay, so it has to touch all four sides of the circle for this rule to work. And my favorite, where it kind of just looks like a million different party hats all in different directions, and they all give the same results at the same angle, and as long as they go from the same points. So that's the key point by there. Next ones, we got so tangents equal lengths. So this is quite good when we're looking at versions later on, because it creates a kite. That was quite hard to say for some reason. But also the fact is that we can use it with Pythagoras. You can use it looking at finding the area of this as well. So it is a good question to have, just knowing that. And again, knowing that they're right angles, okay? So they're hitting, the tangent hits the radius are actually perpendicular to each other, so they're 90 degrees. And that's always the case. So two radiuses, so radii make an isosceles triangle. So that would mean that it cuts at any point and it just creates this lovely isosceles triangle, which you'll be using quite a lot in your facts. And again, the fact that it bisects the chord perpendicular, so that creating that right angle. Last but not least is the alternate segment theorem. A lot of people don't like this one. Just be aware that the inside of your, so from your tangent going across is the same as the opposite angle going right here. Just get that through, and that is the alternate segment theorem. Alternate segment theorem. Just going to raise that now, just so it doesn't go flying forward. Right, so what we're going to do is look at a few different GCSE questions. If you'd like to pause the video now, you're more than welcome to. Just press it when you're ready to listen to the answer. Okay, so we got A, B, C, D are points on the circumference of the circle. The centre O, so that's usually what they use as the centre point, okay? The angle A, which is from here to O to C, is Y. So it's even giving you that point by there, just so we know it. We need to find the size of angle ABC in terms of Y. So ABC is this angle by here. So this is currently unknown. If we think about our first rule that we looked at just a second ago, if I flip it back, we've got the angle at the center is twice the angle at the circumference. So the angle at the center is twice the angle at the circumference. So I can say this is worth half Y. So the angle at the circumference, sorry about my handwriting, is half the angle at the center. Okay, once we've worked that one out, we've then got the other circle theorem coming into play here. And this is where we've got the points A, B, C, and D. They're all hitting the point of the circumference. So we can use that rule that the opposite angles, so this point right here and the one we're trying to find out, are going to add up to 180 because they're in a quadrilateral. Testing my spelling today. Oh, so that is the key point. Just going to check. Yes, I did spell it right. So I can guess myself. And we know that, well, we can write. Let's write this up so we know exactly what we're doing. So points A, D, C plus A, B, C equal 180. So if one of them is half y, which we've already got, let's write that down. So half y plus A, B, C. My writing's going there, equals 180. We're just going to move it around now. So just to get A, B, C on its own, we're going to do 180, take away that half y. Okay, this is more of a proof problem solving type of question. Don't be worried if you don't have numbers and you are working with y's and x's. It's not as bad as it seems. Right, we're going to have a look at a couple more questions and hopefully that will help you out. Next question. Didn't say they were going to be easy though, did I? We have got to work out the size of the angle DOA. So DOA is this angle by here. I'm just going to colour it in. I always tend to colour it in straight away just so it's easier to view. Now we've got a tangent because it's the lines going off. Just going to write mark tangent. And I've also got my radius. So that means that this has to be 90 degrees. Now you might see here that I've suddenly got a right angle triangle. So to find out this missing gap, well, straight away that I can work that out is going to be 90 and 34 added together, which we can do, which gives you 124. Leaving my missing one as 6 and 56. I'm losing it. So that is that point by there. Okay, so we've done the first part. Now the clever thing about this is because we've got that perpendicular thing, it crosses and it's like it bisects the angle. So I remember you might have seen it already. We know this is also 90. This by here, because we've perpendicular, we cut through it. This also has to be 34. So this also has to be 56. And we're just left with this point by here. It's told us that it's a diameter of the circle. So when we know it's the diameter, we can know that this is going to be 180 degrees. There's no like curve in that line or anything. So this point, I'm just going to change my color. So I'm going to do 56 plus 56. And we're going to take that away from 180, which is 112, which gives us 68 in total. I know I did that really weird, but there we go. So you should have had an angle of 68 by there. And that's that question. Next one. Again, pause it if you want to for a second, and I'll go for the answer when you're ready. So we've got S and T are the points of the circumference of the circle with the center O again. So same thing because it stands like origin. So PT is the tangent. So right here, nice to label it. tangent, just taking away the scariness of this question. SOP, S-O-P, is a straight line. So it's just meaning that if there's no bend or slight degree out. And get angle OPT, which is given by here, is 32. Because we got a tangent, means this point right here is our radius. There we go. And the reason for this is because it's going from the center of the circle right to the edge of the circumference. So anytime we have that, when it's going from the center to the circumference, it's going to give us the radius. When we know that, you should remember that rule of 90 degrees, because the tangent meets the radius at 90 because they're perpendicular. So radius meets tangent at 90 degrees. Once we've done that point, we can work out this inside angle. And the reason why I want to work out that inside angle, and that's why I'm deciding to do that, is because I've got a straight line and I want to work out what the other side of my straight line is. So it helps me get the gist of the part of that question. So if I've got 90, I'm going to add on my 32, giving myself 122. And then my final angle is going to be 58. Sorted on that part. Now, if I've got 58 there, we have got angles on a straight line. And that is point by there, okay? Colour it in if you want, it's up to you. I'm just going to write a little note saying angles in a straight line add to 180, which you should be familiar now. This is going to be 122. We're at this stage. We haven't got much left. We noticed earlier that the radius was by here. And in fact, we've also got another radius happening by here. I always write over these questions, by the way, and it's up to you what you feel like. In the exam, I love to annotate what I'm doing just because it makes it easier, especially when it's given reasons, because your thought process, if you're writing your reasons all over the page, you're already like analysing your question before you're answering it. Because we've got two radiuses, we know that this is an isosceles triangle. So using an isosceles triangle, we know it's 180 degrees. So we're going to take away our 122. That leaves us with 58. And we're then going to split that 58 up into 2, leaving us with 29. So that's where the angles come from then. So X is then 29 degrees. And I've just shown it all the way through. Okay, so here is the next question. There's two ways to answer this question. So if you would like to pause the video and I'll go through both questions, well, both answers. So the first one, you got A, B, C, D. This is cyclic quadrilateral again. So we know that ABC plus ADC is going to give us 180. So the first thing I'm going to do is 180, take away that 128. If I take those away from each other, that leaves me with 52 degrees. And then we can use our angle rules that this is going to be double at the center. So 52 plus 52, and that gives us 104. So that's one way we could have done this. If I just go back, and I'm going to erase all the things on the screen, the other way we could have done it is knowing that this angle is going to be, again, double by here. Remember, it's out of shape, but it doesn't matter. Mind my dog. So we're going to do 128 plus 128. It's on a mind of its own. That's going to give us 256. Once we got the 256, we got angles around a point give you 360, leaving us with 104. Okay. And the last question of the day. So again, pause if you'd like to have a quick go yourself, and I'm going to just go through the answer now. So this question has the alternate segment theorem. So the fact that this angle by here is the same as this angle up top. So we know this straight away is 58. We need to work out, it hasn't even told us, has it? No, of course it hasn't. Of course I haven't copied the answer. So that's fine. We're going to just show all the different angles then, just to finish it off for this lesson. So once you know that this angle and this angle are connected, we've got an isosceles triangle that is shown us by here. So we can do 180, take away our 58, which leaves us with 122, living 158 today, and then we're half in that. So 122 divided by 2 gives us 61. So each angle by here is 61 and 61 by there. If, say, you had to work out this inside part by here, that would also cover with the alternate angle theorem, because you got the 61 at this point. This would also be 61 in that angle because they are coincide with each other. Hopefully that helps and you feel a little bit more confident on circle theorems. If there's anything I can do to help, please leave a message. And thank you. Bye.